Hey folks, welcome out there. Hey, you notice I'm not alone this day. I've got someone helping me out, and we are so glad that you're with us. I'm Ernie Roberts, and by the way, this guy is Gary Petco, Supervisor of Mathematics for Knox County Schools here in Knoxville, Tennessee, joining me, and glad to have him with me today. For those of you who are wondering what do we do on this show, some of you may be tuning in for the first time, we're here to help you do some math problems. Give us a call. That number is 844-686-2378. I'll be glad to answer some questions. Gary is here to answer questions.
Absolutely.
Give us calls, all right? That's what we want to hear for. That's what we're here for. We'd love to have wall-to-wall calls on this show today. It's the beginning of a new week, beginning of a new school year for many of you, but a lot of you have been in there for a while, so get those calls ready, get those math problems. That's what we're here for. We've got operators waiting to take your call. And to get you primed, let's take a look at your problem of the day. And here we go. 2/3 of the distance between two cities is 30 miles. What is the distance between them? All right, Mr. Petco, we're going to play this thing together here. And what we got going on here, if we look at our format here, we have distance, we have 30 miles going on, some keywords. I always like to point those out a little bit. And, that 2/3, which we get nervous because it sounds like a fraction, doesn't it? Yeah. Mm-hmm. It's fraction action, folks. We're going to have some fun with it. And Gary likes fractions too, right?
I love it. Fractions can be your friend.
Absolutely.
And I
Friendly
love visualizing
fraction
this.
action.
Yes.
Love it. All right, so visualize. What are we talking about here? Let's look at this thing. And let's play with it a little bit, my friends. By the way, Facebook, my goodness, we've had lots of names today. I have to keep up with them. David, Rhonda, Chip, Mark, Margie, Sherry and Chip. All right. Well, Chip they only chimed in there twice on it. So good deal. And we have it going there. And if you still want to call in on Facebook or check us in on Facebook, please go ahead and put your answer in there too. They seem to all be in agreement. So let's see if we can find it, Gary.
Let's visualize what's going on between two cities.
Visuals are good. All right, let's do it.
All right, we've got a city A and a city B.
All right. That could, well, we know Nashville and Knoxville are not that close together.
No, they're not.
So we'll just call A and B. All right, there we go. And we're talking about how far we got to travel, basically, between them, right?
Correct. When I see that 2/3, I'm thinking, let's see if we can divide that up into thirds.
Okay.
3 sections.
All right. So thirds, I'm cool with that. Mm-hmm. Like that. Hey, I do pretty good, you know. Measure those without knowing that.
That's almost equal.
Actually, yeah, I thought I did pretty good. All right, now, 30 miles is 2 of those, right?
That's right.
So, can we go half?
Go half. That means here? One must be.
So this would be 15. Mm-hmm. This would be 15. Oh my goodness, does that mean?
It has to be.
Well, you told me they all looked alike, right?
They look alike.
So, can't go wrong there. Mm-hmm. So what do we got, my friends? We could add 15, 15, and 15, and we get?
You get 45.
45. Boy, that was solved real quick. Mm-hmm. Now, I'm going to say some things here because that's a visual. It's a good way. Yeah. But, you know, some of our pre-algebra teachers are going to be saying, you know, we can make that into some sort of an equation, maybe?
Which is important because if it were not nice, easy numbers, such as a 15 and 15, we have to have another process.
That is true, yeah. These worked out nicely. That was a good point there. So, but we're still talking about 2/3 of what? Whatever this AB is, to get us 30. All right, so what we're going to do on this, my friends, I like to break, rather than overwhelming everybody in one moment here,
absolutely.
Let's break it into, let's take care of the 3 first.
Let's get rid of that denominator.
Yeah, because we hate fractions, right? We love them, but some of you guys don't out there. So
let's make it more palatable.
Absolutely. I like that. I like that word. Yeah. We'll feel comfortable. We'll be good on it. So let's do it. Let's remove the 3s out of there. Oh, we got to do it the other side, don't we?
Equality.
And let's put a 1 under that because we know it's a fraction. Sometimes those 3s get slipped around a little. So I put a 1 over there. How about it? We'll put a 3 over 1 also. Because that's like that multiplication property of equality. Got to work it through. So 3s, cancel them. And we got 2D left over here. We got 30 times 3. I'm going with 90 here. You know, Gary, we're going to get the same answer, I believe.
I believe we are. You take 90 and
that's the whole idea, isn't it? Just a different way
to
work this thing. Divide by 2. And we've got what? D equals 45.
So it supports our visual.
I like the visual. And in both cases, it's a visual. And think about it. If we go back, and we always like to check. If we were to take 2/3 of 45, I'll drop a 1 under there so we all feel happy. Simply divide that. And by the way, folks, it will go in there 15 times. We'll work it there. And I'm seeing, wow, what am I seeing? I'm seeing 30. Now, how did that check? Because that's what I'm supposed to get, right? Back here at the beginning.
That's right. I think we got
Back
it
to
squared
30.
away.
So I plug in, basically, I substituted into my little business here. And so we're going to take 2/3 of that. By the way, the little word of a lot of times indicates multiply. And in this case, the is just what we want to get. The
Right,
result.
it comes back to groups.
Good
Three
job.
groups
All
out of
right.
4.
Teamwork, buddy.
That's right.
That's a good thing. And folks, now it's up to you. We want to talk with you also here live on the air. So give us a phone call at 844-686-2378. Give us your problems. Give us some things that we can work on and solve together and have a good time doing it. All right, that's what we're here for. And again, that number, 844-686-2378. We've got operators waiting to take care of you out there and don't want to miss out on it. All right, so feel good, all right?
I love it.
Hey,
Man, this is fun.
well, and let's see if we can get some good, more fun audience out there, all right? Give us a call, a lot of friends. And by the way, they call in from everywhere. Middle Tennessee, East Tennessee, Upper East Tennessee. How about it? Western North Carolina, we haven't heard from you lately. Southeast Kentucky, Central Kentucky, oh my goodness. And don't want to leave out Western Virginia. But let's see what we got here. Let's bring this thing in.
Okay.
We got a call. Well, we can bring this out.
All right.
Welcome to Mathline this afternoon. Who are we talking to?
Colin,
Ton, how are you doing? Glad to have you with us here. Where are you calling from?
Smithville.
All right, Smithville. Great to hear from you down in Middle Tennessee. What kind of problem have you got for us today? I have to keep thinking us.
That's right.
Well, I got this quadrilateral, and it starts out like a square, but down in the bottom right, it goes to the left, but it goes up some.
Okay, let's try that again. It starts out sort of like a square, right?
Yes.
Is it a trapezoid? Does it look kind of
Sort
like
of.
this? And does it go like that? Is that possible?
Yeah.
That's what it is.
It's definitely quadrilateral.
Okay. So basically, we've got parallels running here. And we've got, I guess, right angles since you talked about a square, right? And that's how we get that parallel. All right, so let's talk about it. Are there some numbers on this picture?
Wait, my bad.
Uh-oh.
Different drawing.
Sorry.
Redraw? Do we need to redraw?
But in the top left corner, it has 2x. And then on the right corner, it has 96 degrees. And then in the bottom right corner, it has x.
All right,
And
so
then on the left corner, it has 84.
Okay, I think I
all
got
right,
it.
so we got 2x. So we don't have a right. We really don't have a right situation there.
No.
Okay, let's redraw.
No.
Is this a parallelogram?
I think
Coming. What did we say over there? 96.
96 and the opposite's an 84. No, I think it's a
I
parallelogram.
think it is. Opposite angles? No, we can't be, right. Because that's 80, you're 84 down here, right?
Correct.
So let me, well, where? Okay. All right, so we have a 2x. We've got an 84 down here in the lower hand. I'm not going to redraw this picture again. You want to use yours?
Yeah,
You've got
I'll get-
boxes too. We've got a 96, and then you've got an x. Those are your 4 angles, right?
Yes.
Are those the 4 angle measures?
Yes.
All right, great. What we're going to do, how about we add those up and get 360?
Right, and that's the thing.
Also, on the outer parts, on the left, it's an A. On the right, it's a B. And then on the left bottom, it's a C. And on the right bottom, it's a D.
Okay, so we got so big A's, right? Big A, B, C, D.
Yeah, but it's all the way in the top, like top left corner.
All right,
That
so
one.
A is where I marked it here.
Then we go
Yes.
clockwise.
B on the bottom left.
B is on the top
Yeah, I
left.
think we're going clockwise. So B's up here.
Okay, gotcha. And then we got C, and then we got D. Okay, are we
Makes
good?
sense.
Yes.
Let's take these and add them up to 360 degrees because that's where we're going. Equal to 360. You follow where we got that?
Yes.
Because there's 180 degrees in a triangle, but when we put two of them together and make a quadrilateral, we get what? 360.
60.
All right, Gary, what's the next thing we got to do here? I see some things
Now we're
staring
going
at
to start
me.
simplifying. I'm seeing that 96 and 84.
Okay.
I want to add those up.
Are you good with that, Con? We can do the 96 and 84? put them
180.
together?
Yeah. He said it right. Substantive property says we can add them out of order.
Absolutely. So we'll go with it. What is that going to give us? Like 180?
80.
So we're halfway there. And then I'm counting some X's here. And by the way, viewers, remember, if it doesn't have a number in front of it, what number's going in front of it, Gary?
That's a 1.
It's a 1.
It's like a pin.
I'll put a 1 right there to help you. So you got 2 and 1, which add up to 3. Did you ever think anyone's going to ever ask you 2 and 1 to get 3 again? That's pretty good. All right. At this point, so far so good. Are you with us?
Yep.
All right. Let's move the 180, and I'm going to subtract it.
Makes sense. We do the inverse
Absolutely.
operation.
Do the inverse operation, the opposite. So here we go. And we got to do it to both sides because Gary told me so. No.
That's right. Property of equality.
Property of equality. This is subtraction property of equality. So you with me? We good?
Yes.
Say goodbye to the 180s. We got 3x now by itself, which is so much nicer to look at. I like that. And we got a 180 over here. I bet you can tell us what to finish it up with here, Con. What are we going to do?
Yeah, that'd be, you have to put, divide 3 from X to get a variable by itself.
Absolutely.
And the exact same side, you have to do the same thing to the other side. And that'd be 180 divided by 3, and then that would be 60.
I like it. X equals 60. And easy checking, if you're being asked to find both of those angles, one is 60. What is the 2x guy then? 2 times 60?
Okay, and then at the bottom, it says, what is the angle of A?
So that would be the 2x guy, isn't it? What's the measure of angle A?
Yes.
Which, I said, I'm off the screen. Well, let me go back in here somewhere here. That's what happens. Measure of angle A, that equals to 2x, doesn't it?
Yes.
So we just got to say 2 times 60, and that will give you your 120.
And that looks like a good ACT problem, too.
That is, yeah. ACT loves those kind of things where you just take some basic facts, and then you got to come back and do a little interpretation. All right.
Great question.
Yeah.
Hey, good question there. Thank you so much. I agree. I like that. I like that. And thank you for calling us this afternoon, all right? And folks, it's that easy.
Thank you.
Okay, thank you. It's that easy. Con's done it. Let's do it also, all right? Get some more calls out there. 844-686-2378. In the meantime, how about it? Let's eat some spinach. That should make everybody want to call in and get us off the spinach kick.
It's dinner
here,
time.
right?
Let's
That's
do
true.
math.
That's
That's
true.
right.
And spinach is good for you. We're not bad-mouthing the spinach out there. All right. So let's take a look at this one. It says a pound of spinach was marked up from $4.70 to $6.20. They love to gouge you, don't
wow,
they?
that's a big increase.
That's a big increase, absolutely. What is the percent of increase in price? So we're looking for increase means it's growing. We've had to pay more, right?
Right.
So pound of spinach, lovely. There's the numbers that are going to be important to us. And what are we looking for here? What's our game?
Well, you know, when I've got to estimate this. If I'm thinking if it were,
You like to estimate,
I
don't
love
you?
to estimate. I got to check my work out. If it's going to be 100%, that's going to be close to $9. So it's not going to be 100%.
Okay, so we're less than 100%, folks. In fact, I'm going to be willing to say we're less than 50%.
It looks like it's less than 50%.
But we're still a pretty good percent here. It's still a good chunk. So I think what might be important is to know how much you were going to spend 30 cents extra? And then what else were you going to spend?
Well, because I'm going to add up. If I'm going from $4.70, I got 30 cents more, gets me to $5, and then another $1 gets me to $6. So that's $1.30, and then 20 cents. I increased to $1.50.
And you could just subtract that if you didn't want to go
could.
through all that either, too. But yet, I like that. I like that. Going from 30 up to the actual increase. So let's go to a formula here.
Okay.
Because our teachers really do teach a lot of good things with percents using proportions.
Absolutely.
So let's go to it. The part, which by the way, is going to be our increase, how much it went up, which we decided is what, $1.50? We'll put that in there in just a second. And we started with a base. Where did it all begin? Where did it all come from? Well, there we go, right there. And on the other side, percent always goes over 100 because that's what percent is all about.
And I love using that word base because that will transcend when they get into algebra and even pre-cal.
That's true.
The word base.
Yeah. It's a starting point. It's where we worked from. So numbers, which of those two numbers is going to be the base? That's the next question. 470, 620. Which one do you go with?
Well, if we're talking about what was the percent of increase, so that must have meant we started with 470.
All right, so let's put it in there. 470. And what's going on the other side there? We don't know, do we?
No, we don't.
But do we know the part now?
We do know the part. We just found that out.
Yeah.
1.5 or
I'm glad you're here to keep me honest. That keeps me going. All right, 150 there, and why not call it in some number?
Yeah.
And we
Increase.
got 100. Hey, in for increase.
Yeah.
We spell real well
That's
on Mathline, don't we? All right, so folks, now you're working it with us. Hopefully, back there at home. Multiplying by 100 is always fun. And that's one of the things we forget when we're doing percents. We get nervous. And you know, I see students who will go and type the 150 times 100. We don't really need to do that, do we?
No.
Shift that decimal because that means each time you're multiplying by a power of 10 or whatever there. And what do you get?
I'm going to say 100.
You going to think about money? 150.
100 people have $1.50.
That's a good thing to have. Got the good money. All right. Now, and notice I did this because we're cross multiplying here, folks. Don't go across. It's cross on the diagonal. Let's go this way also. How about it? 470 times n. And and by the way, that's multiplication. Don't let these n's bother you, folks.
No.
They stand for numbers. That's one of the things I really have, and I've had people tell me, says, I was doing great with math until we started putting letters in there and doing that stuff. Don't worry, they stand for numbers. They're still helping you out. You're still good for you. And we're looking for the missing piece of this puzzle. So, Gary, you said we're going to add 150. I'm going to go ahead and write down here. Left side has not changed, but move that decimal 2 places, it's $150. Okay, we're talking money, which is important, all right? But we're going to be doing what there? Ooh, what are we going to do? That's not so pretty.
But just like that previous one, when we had a 3x, we're going to do the inverse operation.
And we are going to take, let me rewrite it there so we don't lose track. We're going to divide by 470.
4 7/10.
Which doesn't sound very exciting, but you know if that were fives, you like to estimate.
I guesstimate. If it were 5.
We would be at 30. So we're dividing by a little bit less, so that means it's going to be a little bit over 30, I think.
But I love the estimation part.
Absolutely. Hey, I have to impress you sometimes here. All right, let's do that. Speaking of which, let's take 150, go to the calculator over here, and we will divide it up by 4 7/10 or 4.70. Those you like to put that 0 on there and see what happens. Ooh. Why don't we take the nearest percent? That rambles on forever, Gary. So let's go with approximately, we'll put those little squiggly looking things, squiggly more than usual, and we'll call it 32% roughly.
And I think it's important that it's okay to use a calculator on this because our objective here is to find increase.
And folks, that really and truthfully, just because the numbers work that way, they don't always come out nice, pretty, 25%, 75%.
Absolutely.
This is almost 1/3 though. When we
is.
think of 33 and 1/3% going on and on there. So that's a good point right there. Good benchmark type problem, teachers and students out there both. So once again, we're out here doing Mathline. Gary Petco with me this afternoon. And we want to hear from you guys. And ladies, all of you out there, give us that number, 844-686-2378. And we've got operators waiting to take care of you today. Gary's given his time to come in and join us today. We're having a good time.
Loving it.
So hopefully you all are too watching us. And you know what? How about a Hey Mathline?
How about Hey Mathline?
Hey Mathline. Gary says, what's Hey Mathline?
But I'm all for it's
check
math.
it out. It's math. It is. Let's see what happens here.
Hey Mathline, I'm Addie Smith from Powell High School in Knoxville, Tennessee. I bet you can't tell me the answer to the following problem. Solve for x in 5x minus 4 equals 5 times x minus 4.
Well, Addie, you have given me a challenge, given Gary a challenge here. It says, I bet you can't tell me the answer to the following problem. We're going to solve for x, and look what we've got there, 5x minus 4 on the left-hand side. Then we got a 5 times a parenthesis, and that makes a big difference over there with the x minus 4. It's going to call upon a distributive property moment. And Addie, I'm going to tell you something. I think she's right. I don't think we can tell her the answer to this.
I think we can tell her an answer, but not the answer.
Sure. Yeah.
That's different.
We're gonna have to look at this thing in an interesting light. So first of all, we know what happens with these parentheses. It's time to
multiply.
And the big D, big distributive property coming through. And I always use the arrows, kind of keep us straight on those, because a lot of times we do 5 times x and forget about our friend out here, and that will make a big difference in this problem as to what we get for
Absolutely.
a solution. So let's go with it. 5x minus 4. We got 5x going here. But what happens when we do that 5 times the negative 4? What are we going to have?
I'm going to subtract 20 or a negative 20.
I like the negative 20 also. All right. Now, here's where we all go crazy. All right. Well, we don't really go crazy, but we start looking at this thing, and that bothers me. It bothers students because when they subtract 5x, which is what they've been told to do, right? We're going to move, balance it out. So here we go. Uh-oh. Goodbye, X.
Yeah, all of a sudden something disappears like a magician.
Wow. And all of a sudden it's like, what do we do? What do we do? Well, let's see what we do. We have a negative 4 equals negative 20, which then gets my students excited because they said, oh, we can divide negative 4 into negative 20. The answer is 5. That's not quite, and with 5, because, well, 5 was up there. I guess that would make it work, all right? So what's the problem here? That can't be.
Cannot be
I
equal.
don't care how hard you try. This side is always going to be what? Smaller than this side. So, Addie, you know, you challenged us. You said, I bet you can't tell me the answer. She's right.
She's right.
There is no answer to this.
No
You say,
solution.
what? You know, there's always a math problem answer, right? That's always what they say. But sometimes we get a no solution situation. Let's look back at the original statement. Gary, no matter what, actually, when we go
That
to
second
here,
step.
I like that second step. Get to that second step again. And no matter what we put in for x, this one's always going to be a minus 20, and this one's going to be what, minus 4.
4.
There's no way we can ever make them work out.
Yeah, you can't subtract subtract a 4 and subtract a 20 and get the same answer.
Wow. So in this case, Addie, you got us. No solution.
Good job, Addie.
And again, thank you, Powell High School, on that. We enjoyed having Addie with us for doing a Hey Math Line. It's another thing, folks. You all can, in your schools, let us know. We'll come out and visit you. Come out and film a Hey Math Line with some of your students and have a good time putting some of the problems that they have into words and, hey, giving it to us on the air, and we can work them out for everybody to see. And remember how to go with that.
Powell Math rocks.
All right, absolutely. You know those folks at Powell High School.
Absolutely.
They're great. They were great. Alice Carson introduced
Kim
me
Shipley.
to this group.
Yes.
All right, so glad to have them with us. Now, how about it? We've done a little high schoolish stuff. We've done a little middle school stuff. Can we do a little decimals?
I'm gonna love this one.
Are we ready for some decimals? No one calls in on this one.
Oh, I'm loving this one.
Ooh, this one has a simplify word, which simply means we're going to get down to one number. Let's take it down to one number. So we've got, folks, just look at what we got here. We got 600 divided by 500ths. That's with a th. And we got 450 times 200ths. All right. So my thought is, my dear Aunt Sally,
You could. I'm going to
you want
estimate.
to start? You could estimate.
I'm going to estimate.
Go for it. Let's estimate, because we're going to have to move fast on this
Okay,
one.
I'm going back to
probably.
money. That's $600 divided to how many nickels? Because 500 is a nickel. How many nickels are in $6?
Okay, all
Okay,
right.
go for it.
All right. So how many nickels are in 6?
I would say it's 120.
120? 120 nickels and $6. All right. So what else do we have to do? We have some more zeros because we're going to have a
I don't think we have to, because I think 600 divided by 500 should be 120.
be 120. Let's look.
Let's see.
Let's see. I'm going calculator on this because you know that decimal. Got to be careful. We divide by hundredths. Woo!
Oh,
we
look
had
at
some
that.
zeros.
12,
We
yeah.
had some zeros.
We gotta add some
now
zeros
you can
on that.
divide 5 into that, but you got to move some with hundreds.
right.
You got to move that. So folks, be careful on decimals there. So here we go. 12.
Yeah, if it's $6, it's going to be 120, but we got 600.
Yeah. So that would be definitely, that makes sense, all right? Now, let's estimate over here. I think we can double.
I think we can double it.
And what can we do from there? Move the decimal a couple places?
That's right.
So that's going to give us a 900. And all of a sudden, we're going to agree, all right? We're going to be happy on this. We don't even need to go to the calculator. We're just going to take 12,000,
Plus
add it to 900. Wow, 12,900.
900.
Now, just a quick moment here. Let's go back to our little controversial moment here, all right? And this is what usually look at, and this is what students call in on the phones here and say, sometimes they'll say, I have 500s divided by 600. No. It's 600 divided by, yeah. So once again, we are going to multiply by 100 so we can get rid of that. But look what happens when we multiply by 100 over here. We're throwing some more zeros in. And so another option here, how about it? Goes 12 times, right? 0, 0, 0, and there we go.
There's our 12,000.
So a couple of ways to work with it. I like your way to estimate, I really do, and then multiply it through. But hey, folks, thanks for tuning in today. Hey,
thank you.
Con, thank you for calling. Gary, thanks for being with us.
You.
He's going to be back again tomorrow. So get some math questions ready for us, all right? So we want to go wall-to-wall questions tomorrow. And again, thanks for being with us, and we will see you once again next time.